it seem like we're talking about air, but we're actually doing, I'll be doing the problems on my desktop or my, I don't know what it's called. Okay, so okay, I'm looking at as many as I can. Raise your hand if you want me to go over that problem on the pair deck. Raise your hand. Okay, no one. You guys all know how to break that thing down? Okay, that's great. I will move on then. Next one. Okay, raise your hand if you want me to do that one on the pair deck. All right, this might be a very quick class. Okay. There's the answer. 2 answers. Just so you know, make sure you know how to factor that. Okay, multiplying exponents with a fraction and then plugging in the number with an exponential fraction, plug in -8. Raise your hand if you want me to do that one. Well, this is very interesting. Okay, well, you guys. There's the answer. See how complicated it is. Okay, but, okay. Solving for the inverse of this function, okay? You don't want me to solve the inverse of that function?
Can you at least do that one?
Oh, no one's raising their hand. Who said
Wait,
that?
can you do the last one?
Wait a minute. People don't want to do it. I'll let those people go, and then I'll go. We'll do that. Sounds like a few of you want me to do those. So not enough to do this one. Okay. Inverse of the function. Oh, you also have to determine if it's a function or not, too. Okay, on the test. Anyway, so I'm moving on. Determine that. So this is another one. Find the inverse and determine if it's a function or not. That's it. All right. Any questions? All right. If you're ready for the test, study on your own. You can study on your own right now. You may go. Otherwise, if you want to stay, you can stay and we'll just do some problems. And I'll explain the inverse concept better. Bye, Max. Bye, Seth. Bye, Giselle. Bye, Isaac. Bye, Sienna. Bye, Irvin. Bye, Camilo. Bye, Caitlin. Bye, Virginia. Okay, how many people are here? 14? Well, some people still. Okay, hey, the only way I could do this is I'm just going to start doing problems. You can, I don't know, if you're here and I do a problem you don't want to do, you could just, I don't know, go to the bathroom, have a snack, and then come back, whatever. Okay, but here we go. Okay, simplify. I'm going to do this one very quickly. Simplify this fraction just to make sure you can break it down. Actually, let me go like this. Which ones do you guys want me to do? Anyone who says, I'll do anyone, the first one who says, what's that?
The one that was like the third to last one, I think it was.
All right, Claire, I'm talking to you since you answered here. This, multiply, divide, the inverse?
No, I think it was one before that.
Multiply and divide, then substitute.
Yeah,
So
that one.
All right, cool. I have this is number 10. I just got this from your homework. Okay, and let me write it down and then I'll show you me working it. Actually, you know what? Why don't you guys go solve it and see what you get? I made this whole pair deck thing. I was up all late last night doing this pair deck, and you guys are, Why don't you guys, since you all know it, let's see how smart you are. All right, go ahead and first multiply, then divide. So let's do the multiplication first. Put the answer on, see what you get. Put the answer on, see what you get. It's asking for the domain. You have to be able to list the domain. All right, I'm looking at your answers. I'm curious if you guys can actually do this. Class is getting a little cocky here. And I don't need this. What I put, is it a draw thing? You can't, did I put draw? Can you not type it in? Oh, well. Guess you have to write it in. Multiply. You have to draw it in. Oh, is that harder? Would you draw it? Look at that. It's kind of cool. You guys are drawing it in. Then you have to plug in -8 to that sucker. I got my calculator for this. Okay. I'm going to show you guys the answers that I got. This is, I don't know if you guys are seeing that this is harder than what it seems. The answers are coming in pretty slow. I don't know if you guys are not getting it or you're just not doing it. All right. Okay, this is right. This is F times G, and I believe this is right. Negative, what is that? Holy crap, what is this? 1, 2, 3, negative 5,446,272. I think that's right. Anyone else get it? There, yeah. Okay, I'm gonna do it. Here we go. Let's do F times G. So I have here f of x equals 11x cubed. And then you have to be able to list the domain and range. Okay, so wait a minute here. Oh, I can't find my, I was trying to find I don't know where my document camera went. I had it all set up. Oh, there it is. I guess it wasn't connected. Do you guys see my document camera? Okay, so okay, F times G is 11 x cubed times 7x to the 7/3 power. So this is easy. 11 times 7 is 77. Now x cubed times x to the 7/3, remember we have to add them. So I'm going to do over 3 over 1 plus 7 over 3. You want a denominator of 3. So this is 9/3, 7/3. 9 plus 7 is 16 over 3. That's f times g of x. All right. Now, they say, what if f is -8. First of all, what's the domain and range? Well, what's the domain? The domain is, as long as this is not a 2 in the denominator, you can plug in any x that you want. Or even, as long as this denominator is not even. Because remember, if it's even, you have to find two. If you can't do negative numbers, like you can't get the square root of -4 because two times you need a positive and a negative. So as long as this is even, you're good. So f of -8, so it's 77 to the -8 to the 16 over 3. So remember, order of operation says we do exponents first. Holy crap. So this is 77. I'm going to cube it first, and then I'll raise it to the 16th power. The cube root of -8 is -2. 77 to the -2 raised to the 16th son of a gun power. That's -2 times -2 times -2 times -2 times -2 times, every 16 times. I can't even think of that. Can you guys even see my calculator there? Let's turn it on, see if you guys can see it. Anyway, you just raise it really dark. I feel like I have a light on this thing. Oh, I think it's right here. Okay. So -8. -8. Got to put in parentheses. Whoops. -8. And then my exponent is this little kick up key for this calculator, raised to the 16th power. Nope. That's 2.8 to the 14th times 10 to the 14th times 77. So it's 2.16 times 10 to the 16th. Wait a minute. Is that right? I got a different number. We got 50,000. -2. Why does the book get a different number? F times G. Maybe I calculated that wrong. Hang on, let me see. Oh, -8. That's -2. I'm sorry, I put -8. It's -2, right? -2 to the 16th equals times 77 equals that. Oh, sorry. I put in the wrong number. So that's the number you should get. 50, what is that? 5,046,272. Okay, but now let's do F divided by G. So F divided by G is F is 11x cubed divided by 7x 7 to the third. So basically you're going to subtract, instead of adding these, you're going to subtract them, is 2/3. 9 minus 7 is 2/3. So it'll be 11 over 7 x to the 2/3. Let me double check to make sure my answer is correct there. Yep, it's right there, right there. And then you got to plug in, okay, so x, the domain, the x cannot be 0. I believe it's all received. Why can you not put in 0 there? Let's see. 2/3. I think you could put 0 in there. Let's try it. 0 raised to the, yeah, 0. Why could you not put 0 in there? That doesn't make sense to me. I would think the domain is all real numbers. Because x is not in the denominator. 1, 2. Oh, wait a minute. Yeah, x is in the, it should be all real numbers for the domain. So let's do 2/3. So let's put a -8 raised to the 2/3 power times 11/7. So -8, you can cube that, and then you square it. -8 cubed is -2. -2 is 4. 11/7 times 4, which equals 44/7. Oops, sorry about that. Let me show you my work there and hide this. And that's it. Clara, was that good? Let me show you the answer first. I'm asking if you didn't even see what I did there. So I plugged in -8 to the 2/3. I got the cube root of 8, which is -2. And then I squared it. -2 times -2 is 4. Then 4 times 11/7 is 44/7. That's F. That's F over G with -8 plugged in. All right. Are there any questions on that problem? Looking at you guys.
Did we have to say the domain and range?
Just the domain.
Okay, so then what's the
The
domain?
domain is all real numbers for both of them.
Okay.
So remember, what you're looking for is if the denominator is even, then you cannot put in negative numbers for the domain. That's the main thing you're looking for, if it's even. The other thing is if x is in the denominator, then you can't do 0. But this one, the x is not in the denominator, you should be good.
Is the test multiple choice?
It is. Okay. Are there any other questions? Let's see. Let's go over. Yeah. Any other ones you want me to specifically do? I'll start clicking through them. You guys can say, "Hey, I'm in the pair deck now." Oh, I'm just click. If someone speaks up, do you want me to do something? That's the answer. Solve for the inverse, and that's the last one. Determine the inverse is a function. Solve for the inverse, and determine the inverse is a function. With all of them. All right. While you guys are thinking about it, I'm going to explain, Jade, I'm going to explain the domain and range, or the inverse real quick. Is that cool? That was a great article. I read it that you sent, or you sent me 2 things on it, right?
Yeah.
Okay. So, okay. All right. The idea behind the inverse, or actually specifically, before I start talking, let me hear. Do you have any? What are your thoughts, Jade? So I can make sure I address what your question is.
I just want to know why you have to switch the x and the y to solve.
Okay, perfect. Okay, so the idea behind the inverse, like in real life practical things, is so that we can, like in real math, I gave the example in that article you sent me is like changing Fahrenheit to Celsius. And I can't remember the equation for that, but you should be able to go from, like, you should be able to, if here in America, we use Fahrenheit, right? And if someone from Italy came over and said, how hot is it? They'd have to take that number, plug it in an equation, then convert it to Celsius. But then you should be able to take that number too from Celsius and convert it back into Fahrenheit, right? The easiest example, I think, I like to break things down to simple examples, is let's take pounds, pounds and kilograms. Okay, now in America, we mostly use pounds, and other countries use kilograms. However, if you work in the medical field, and I did this a little bit, you have to give people medications based on how much they weigh. And in medicine, they calculate their drug dosages based on kilograms. So whenever they ask someone how much they weigh, they say, I weigh 180 pounds. Well, the thing is, they have to convert that to kilograms. And then they have to make their drug calculation. So they have to figure this all out. And a lot of times they do it in their head and stuff like this. And it's actually not that hard to do because 1 kilogram equals 2.2 pounds. Okay? So if someone weighs, let's do an easy number, like 50 kilograms, well, you multiply it by 2.2 to figure out how many pounds they are. So anyway, so this is how it would work. If let's do it easy. If someone weighs let's see, how do I say this? The way you'd convert it is you take 1 kilogram and you'd multiply it by 2.2 to get the pounds. Okay? So if a person weighs 10 kilograms, not that they weigh 10 kilograms, you multiply by 2.2 to get the pounds. Okay, so let's write that as now to go from pounds to kilograms. So let's write it as 1 kilogram. Let's make a formula times 2.2 equals pounds, right? Or let's change it to 2.2 kilograms equals pounds. To go from kilograms to pounds, I have to take the number and plug in the number for my kilograms, multiply it by 2.2, and I get my pounds. Okay, so now what if I want to go from pounds to kilograms? Well, what you have to do is, let's do it over here. If I want to go from pounds to kilograms, I solve for K. So I divide by 2.2, and I say 1 kilogram equals pounds divided by 2.2. Okay?
Wait, Mr. Sanchez, we can't see your screen.
Oh, shoot. I'm sorry. After all that, I'm so sorry. By the way, if you're like rather do other things, you don't have to. You can go ahead and go anytime that you want. All right, you can go anytime that you want. Let me start over again. Okay, can you guys see my screen now?
Yes.
Okay, so basically, here's basically what I was saying. Okay, to convert kilograms to pounds, you take 2.2 multiplied by kilograms, and that's going to equal your pounds to keep it simple, right? So if someone weighs 50 kilograms, you go 2.2 times 50 and you get your pounds, right? So that's kilograms to pounds. But what if I want to go from pounds to kilograms? Well, you have to solve for K, right? And so let's do it here. So I want to get K by itself. To solve for kilograms, I want to get K by itself. What would I do to get this, to get K by itself? What would I do?
Divided by 2.2.
Yeah, so I divide by 2.2. And now they'll tell me, hey, how many kilograms? If you want kilograms, you got the K by itself. You say pounds. You take the pounds, you divide by 2.2. And that'll give you the kilograms. So, and that is the inverse. That's what inverse is for, right? So that I can go from kilograms to pounds and then pounds to kilograms. Now, what did I not do to figure this out, though, that I told you to do at the beginning, Jay? Do you remember? The thing that you're... What's that?
To switch them?
I didn't switch the P and the K. If I did that, then that would change. If I switched it, if I did what I told you for going from kilograms to pounds, I said, hey, find the inverse. And if you said this is what the article was saying. If I said, okay, well, switch the pounds to the kilograms. See, I did that right there. to find the inverse?
Yes.
Okay, so now I'm going to solve for P, and what I'm doing is I'm messing the whole thing up here. And now I'm saying pounds equals kilograms divided by 2.2, right? For a practical thing, this would not work, okay? But the inverse is where you switch the P, and the inverse is basically you want to get the other variable by itself for practice. So for Fahrenheit and Celsius, right? You want to get to find Fahrenheit, you want to get the F by itself and plug in C. To find Celsius, you undo everything. You want to undo everything and put everything for the Celsius, so you can plug in Celsius and get the Fahrenheit. But anyway, that's what we're doing here. Now, what they were saying was you don't teach, like, if I want to find the inverse with the Y and K, it doesn't really practically explain what the inverse is for in a real life situation. Inverse in real life situation is just switching from one unit to the next unit, okay? But for what we're doing in the classroom, the reason why we switch the X and Y is that so you can find the actual graph difference. We were graphing them. So you're switching them so that you can graph the inverse. Because when we do the graph, the X is still the X-axis and the Y is still the Y-axis. So I'm not doing a good job of explaining that. So I'm going to say one last thing. Overall, the whole point of the inverse is to undo what you did. Like, for example, to find the inverse, right? To find the inverse of this is y equals 2x plus 1. To find the inverse, what am I doing? I'm multiplying x by 2, and then I'm adding 1. Okay, but in order to graph it, like if I didn't do the switching, if I didn't switch the x and the y, which I can get the inverse of this by getting the x by itself. I could do that, right? This would still be the inverse, Jade. Y minus 1 equals 2x, right? And then I divide by 2, and I get y minus 1 over 2 equals x. So those two inverses would be correct. So the first one right here was y equals 2x plus 1. And the other one is x equals y minus 1 over 2. These are inverses. I didn't switch the x and the y. They're inverses, right? Like you said, look, I'm multiplying by 2 by x, and then I'm adding 1. The inverse would be subtracting 1, then divided by 2. These are inverses. Why did I switch the x and the y? Because I cannot graph this on the same coordinate plane. I can't graph plugging in y and then solving for x. I still need the x solve for y in order for us to do the graph. This would not translate on the graph.
I see.
Sorry, I know I went all over the place. I hope I did a better job explaining that. But are you just saying that so that we can get out of here?
No, I got it. Because yesterday when I tried graphing it, when it was x equals y something, the graph would turn out different than the y equals x something. And
It would be the same graph. Like if we graph these, like let's take a look. I'm going to graph them on Desmos right now. Let's graph them on Desmos. It should be the same graph. Because I didn't switch the x and the y, it'll just be the same graph. Like this right, I'm going to graph y equals 2x plus 1, and then x equals y minus 1 over 2. Let's graph that on Desmos and see. Because it's the same formula. Y equals 2x. Now there's y equals 2x plus 1. And this is what I'm deductive reasoning on this. So hopefully I am correct. Let's see what happens. Y minus 1. Oops. All in parentheses. It's underneath. Divided by 2. See, it's the same graph. That's the inverse. But if we switch the x and the y, then you'll get the inverse as a function in the graph. So it would be y equals x minus 1. Now I'm switching the x and the y's. Now we'll see what the inverse looks like as a function. There's the inverse. Okay, and this one you'll see the x equals the y and the y equals the x. But again, I should have stressed that the whole point of inverses is for like real life experiences when you're converting everything. All right. So are there any other questions? Tomorrow's the test. All right. So just study, just make sure you can do those problems. Make sure you can find the domain and the range and all that stuff. Okay, domain and range. And if you can identify if it's a function or not. Okay.
How
The
do you
inverse. Yes, Viela.
how do you identify if an inverse is a function?
Okay. That's going to be a little bit, this will take a little bit for me to explain, if you don't mind, Viela. You cool? You okay? Okay. You know what else? You guys can, if you want to stay, you can. If you want to go, that's totally cool. Don't worry about it. Okay. First of all, let's talk about what is a function. I'm going to go, Viela, I'm going to go from the beginning and talk about like what is a function, what is not a function, okay? Is that cool? Because I feel like I should say that. Or do you know what a function is and what not a function is?
Yeah, you can explain it.
Okay. Okay. Here's a basic definition of a function. And it's when you first hear it, when I first heard it, it was like confusing. But a function, each input has only one output. Okay? Now, what I mean by that is a function, each input has only one output. Function from the basic definition of a function has one and only one output. I'm just gonna put one output, but it has one and only one output. Now, what is our input usually? Input is x, right? Output is y. So here's a function. 0, 0. 4, 2, 1, 1. 9, 3. Okay. 16, 4. Okay, that's a function. Got it? Now, let me do another example here. Let's do just a random number. The best thing is to see what's not a function to understand what a function is and what a function is not. But each input has only one output. Let's go 7, 3, 2, 1, 4, 6, 8, 9. That is a function too. Okay? Let me ask you this. 3, 9. Is that a function now? What do you guys think? Is this still a function? Is anyone there? Take your anyone? What do you think? What do you think? Who else is here? What do you think, Strummer?
I don't know. I didn't get to see it fast enough. I'm still writing down the numbers.
Oh, that's cool. You're just kind of hanging out. Ishi,
Yeah.
what do you think? Is this a function?
No.
Actually, it is. It is a function. Still a function. Why do you think it's not, though, Ishi?
Because there's two things for 9.
Yep, but it still is. Remember, okay, these are the inputs. These are the outputs. Okay, let's make sure you all understand that. This is not a function. Now it is not a function. Okay? Jade, why do you think that's not a function? Or why do you know that's not a function?
Because 2 of the inputs are 4, but they have 2 different outputs.
Very good. Input 4, I get a 6. Then I input 4 again and I get a 3. The 4 has 2 different outputs. Okay? You can have inputs with the same out. Yeah, you can have inputs that have same outputs, but as long as 8 only comes out of 9 and 3 only comes out of 9, it is still a function. The thing is, you want to look on the x side. If I plug in 4, I get a 3. I plug in 4, I get a 6. It is not a function. Okay? Now, what if I change this to 6, though? Is it a function now? What do you think, Ishi? Is that a function now?
Yeah.
Why?
Because
It is, you're right. Why?
they're the same.
Yeah, because the input 4 still has only an output of 6, right? The input 4 only has an output of 6. Now, this here, can you tell what I'm doing here to get what I'm doing to my x in order to get for my y here on this function here? What am I doing?
You're taking the square root.
I'm taking the square root. Now, generally when we graph square roots, you know, they look like this. We go, hey, square root of 0 is 0, square root of 1 is 1, square root of 1, 2, 3, 4 is 2, right? And it looks like this. And it is a function, the way we graph it. But, and this is the way we generally do in math, it's agreed, everyone agrees to get the square root. We only get the square root of the positive numbers. But the square root of 4 is 2, but what else is the square root of 4?
-2.
It's also -2, right? All of these. Square root of 16 is 4, but it's also -4. Right? So you see right here, actually, the square root of 4 has 2 different outputs. It has 2 and -2. If we were graphing it without all the nice little math rules that we agree upon, the square root would actually look like this. 1, 2. You'd have this right here. Am I in the screen? Can you guys see that? So really, when you get the square root, you're really getting a positive and a negative. Okay, and when we do the inverse, we kind of ignore that rule. We kind of ignore it. The rule where we just graph the square root, this here is y equals the square root of x. We kind of ignore that. Now, we ignore just square the positives. We also square root we find the answer of the negatives. Now, you guys probably remember this. If I take the square root, you ever hear the vertical line test? If I draw a vertical line, so I'm looking for my orange. I'll use my blue. If I drew a vertical line here, see how remember they said it can only intersect once, but it intersects twice. This shows it is not a function. Why? Because at this line, where x is equal to 4, I have 2 outputs, doon, doon. The vertical line shows it has more than one output. If it crosses more than once, it is not a function. Now, after all that, basically what you guys were asking, you're going to, Sensei, you're talking so much. Whenever you have let's say, we have y equals x squared. Let's find the inverse. You switch the x and the y so that we can graph it. You take the square root, and it's going to be the inverse is going to be y equals the square root of x. That's the inverse. Now that we did the inverse, we ignore that rule where we just do the positives. It's actually going to be positive and negative the square root of x. Whenever we get the square, we get a positive and a negative answer. Whenever you see that, or if you see a square, it will not be a function. If you see anything, like if you see y equals x squared plus 2 all over 8, if you see a square in there, the inverse will not be a function because we will have a square root. But wait, there's more. If you also see an even number as an exponent, the inverse will not be a function because I need 2 numbers or 4 numbers, which is even, to get that negative number. So long story short, if you have a function and you want to find the inverse, if you see an exponent that is even, the inverse will not be a function because of that square root effect. Okay, I can't remember who asked that. Was it Ishi who asked that, or was it Viola asked that, right? Are you still here, Viola? Did that answer your question?
Yes, thank you.
Okay. Was that your mom you're talking to, Viola?
No, it was my sister.
Oh, tell her I said hi. Wait, what grade is she in? She go to Oxnard?
No, she's a senior in college.
Oh. Did she go to Oxnard before? Okay. Where'd she go to school? VC?
Berkeley.
Oxnard? Huh?
Berkeley.
OC. Berkeley? Oh, she's here? Berkeley, dang. That's great. Holy moly. Good for her. Does she like it?
I think so.
Can she hear me talking about her?
No, I have.
Oh, no, because you hear the headphones. All right. Hey, do you guys have any other, I'm sorry, do you guys have any other questions? All right. Well, good luck on the test tomorrow. Study. See you, Stormer. See you guys. Bye, Ishi. Bye, Jade. And I.